Hello, hi everybody. Welcome to the last community meeting of the year for Kubewarden. I'm Flavio Castelli from the Kubewarden project, and today I'm going to be your host. So, welcome to everybody. As usual, this meeting is recorded and is going to be shared on YouTube. So, if you're watching it, feel free to reach out to us to leave comments about the things that we're going to show. And don't be shy, feel free to join these meetings. They're open to everybody. We hope you enjoy this meeting. So today on the agenda, we have two items to be discussed. The first one is about some house cleaning that we have been doing, some technical debt that we have started to address. And for that one, I leave the stage to Fabrizio to talk more about that.
Yeah, so since it's Christmas time and we thought, to be prepared for the new year and new adventures, we started doing some technical debt and house cleaning. And I personally worked a lot in the testing, and other team members, they work a lot on error handling and even optimization. But I will let them talk about that. And about testing, we decided that we wanted to do something project wide, and try to revisit a little bit how we test things and how we layer tests, especially. And then those brought us to also make some changes in the code organization that help us to extend the code even more. So the first task was about mainly the Kubewarden controller. So we were using, we were having unit tests there and some integration tests. And then we were relying a lot on end-to-end tests, which are still really important when we do the release. But we were missing some steps in the middle, especially in the integration test. So we were testing with mtest, but not running the tests against a real cluster. So mtest is like a framework that comes from Kubernetes controller runtime that helps you to spin up a fake control plane. And the control plane is basically like an embedded etcd, and it has no Kubernetes built-in resources. So what you can do, you can have your tests running against it, but it will stop on the objects that your own controller reconciles. So for instance, we were creating a policy server, and then that was spinning up a deployment, and there was no Kubernetes, like reconciler that was taking the deployment and spinning up replica set and then pods. So we couldn't, do the whole test of the whole scenario. So the first thing, like we added a real cluster with the test containers, and that works really well actually. And we're pretty satisfied with test containers because a developer, or even in the CI, we don't have to bundle dependencies, or like having to rely on Docker Compose or some other clusters like Kind or K3D. It does it for you automatically from within the test suite in Golang. And then by doing that, we were able to test almost, like, I think we reached the 82% coverage on the controllers, which is quite nice. And this is also like preparing for the changes that will come in next year, including some search manager removal, or even adding more features to the controller itself. And then the other part of the testing was in policy server and in policy evaluator. So we were relying a lot on end-to-end tests and policy server, and those were kind of like testing some runtimes bits of the policy evaluator, such as like seeing if the policy, I don't know, Rigo runtime or the WPC runtime or the WOSI runtime or the raw policies were working. And we worked a lot on and inside the policy server to add integration tests there that were more related to the APIs. So testing if the controllers were working all right, and you had all these like kind of like contracts with the outside world. If I do that, I get a 404. If I do that, I get a 200. And then we moved this end-to-end test. Actually, we are moving this end-to-end test as a part of the policy evaluator testing as an integration test by using just pure Rust. So we moved. We are planning to remove a tool that we were using, that is Venom, that was handling the end-to-end test of the policy server from an external point of view, and we were relying even more on Rust to do the integration tests in the policy server for the API, and then in the policy evaluator for the runtime. And right now we are also working on extending the test for the context-aware resources. We were a little bit lacking there, and we are adding even more tests there, and especially with the new features about adding context-aware capabilities to Rigo and OVA. So we are also extending the context-aware capabilities to other runtimes. Is especially important to have that tested well. So we are working to work on the integration test for the policy evaluator, also the context-aware capabilities. So that's, I think, basically it. I don't know if I'm missing something.
That's quite a lot. Yeah. You mentioned that we are doing some improvements in the error handling space. Does someone want to add something, or was I can? Okay. So this is pretty Rust specific. So we have some libraries that are part of policy server, like policy evaluator or policy fetcher, and they are raising errors, but we were not typing our errors, so they were just all the same type of error using a popular Rust crate called anyhow. Now we are providing typed errors, so different error types, different error reasons lead to different error types. And this is good because it allows us to do better handling of certain types of errors and better recovery strategies, or better error messages and such. So this is some work that we are currently doing, and it's mostly done, I would say.
It also helps us to, maybe if someone wants to consume our crates as libraries, you never know, then they have a fixed contract that they can rely on when a function returns a result, and do their rendering in a more kind of like ordered way, or and that's good also for us.
Yeah. And this kind of code changes, they also reminded me that during this month we also improved, extended our coding guidelines to provide more, let's say, rules, guidelines about how to write Go or Rust code. You can find all the guidelines in case you are interested inside of our GitHub repo. We have inside of each GitHub repo, there is a file with the coding guidelines that points you to the central location where we keep history of the guidelines. And you're welcome to contribute to these guidelines in case you find something that is missing or something that you might not agree with. We can talk about that and improve them. We're always eager to learn new things. I would move to the other topic, which is about policy server and the memory usage of policy server. So we had some reports coming from the community about policy server using quite some memory. There is an issue open for that. I can try finding it. Yeah, I don't know if this worth to be shared. However, yeah. So we have this user who reported that he has 61 cluster-wide policies deployed on this server and on this policy server, and as a result, the policy server is using a lot of memory. By digging through the issue, there are definitely some architectural choices that we made with policy server that lead to increased memory usage, and I will discuss them afterwards. But then it looked like some of the policies that this user was running were actually doing memory, leaking memory, and so over the course of the lifetime of the policy server, the memory usage went up because of these memory leaks. And there is also an architectural decision that we made some time ago that could and can lead to this kind of scenario. Of course, memory leaks inside of policies are something that should be prevented by the authors of the policies, but there are still cases when this might happen. So it's we think that it's important for us to address also these cases. And so to summarize, we had architectural decisions that that lead to this kind of scenarios. And so we started a journey of doing iterations over the architecture of policy server, trying to find a solution to these problems. And so I'm going to share with you the screen and show you an issue that we're using to track the work on this topic. Can you see my screen?
Yep.
Yes.
All right. So this is an ongoing pull request done on policy server. It was started 1 month ago with some preliminary work. So this is an issue. This is a pull request that summarizes, what has been done. So this is the first iteration, and the more you go down to the bottom, the more changes happen, and then we end up with the final iteration. So what has been done? So first of all, how did we test it? So as I said, this user had 61 policies deployed, and that means that he had multiple instances of the same policy deployed. It is not uncommon to do that because you might have the same policy deployed inside of different deployed to target different namespaces, or deployed inside of different namespace, thinking about admission policies that are namespaced. But even if you have multiple cluster-wide policies, you might want to have some namespace selector or object selector, and that leads to have same policy deployed different times with different settings, or maybe a different policy mode. Maybe one is in protect, the other is in monitor. But what matters is that you have, like in these benchmark data, you have the same policy loaded multiple times. And so this is basically a set of policies. We have some duplications, 1, 2, 3, 4, 5 instances of the same policy. We have this unique policy, this other unique policy. We have this policy duplicated twice, and this is also a WASI policy, which usually is pretty fat because of how the Go official compiler produces WASI modules. They're pretty fat. And then we have 1, 2, 3, 4 instances of the same policy. So we run some benchmarks. All right. So these are the current date numbers. For current, I mean, if you take the latest stable release of Kubewarden and you start it up with this policy configuration, and you configure like one worker, you end up using usually this amount of memory. If you have 2 workers, you consume more memory. And as you can see here, and as you can see inside of this this chart, the more workers you have, the more memory is being consumed by policy server. And why is that happening? This is happening because the way policy server works is by having an internal thread pool of workers that are there to process the incoming request. Each one of the worker has, used to have, right now has, a WebAssembly sandbox per each policy defined by the user. So if you have 5 instances of the PSP policy like before, like shown above, each worker will have 5 WebAssembly sandboxes for this policy. And so you end up having a lot of duplicated memory, all right? So the first iteration in terms of optimizations brought us to a lower memory consumption, as you can see. It is still growing. The more workers you have, the more memory it is using. But compared to the current implementation, the memory consumption is pretty reduced. And so the more workers you have, the more memory you save. If you have 8 workers, you end up almost saving like 50% of the memory. The number of workers, by the way, is configurable. It's tunable by the user. But if you do not specify that, then policy server will allocate 1 worker per CPU core of a machine where it is running. So if you're running policy server on a beefy machine with many cores, then you have multiple workers and you end up having, this memory usage. All right. So how did we manage to reduce the memory usage in this case? We did that by deduplicating the policies. So to be more specific, we deduplicated the WebAssembly sandboxes. So in the previous example here, we have 5 instances of a pod privilege policy. So we do not need to have 5 sandboxes for the different pod privilege policies. We are just going to allocate 1 sandbox for the pod privilege policy, and then just 1 sandbox per worker. So we're still talking about a specific worker. Each worker will have just 1 sandbox of policy. And then this sandbox is going to be reused across all the different pod privileged instances. And at each evaluation, it's going to use the right set of settings. So why didn't we do that since the beginning? We didn't do that since the beginning because it was a bit complicated to ensure that by reusing, we want to reuse the sandbox, but we do not want to, we still want to allow each policy to have different, each instance of the same policy to have different settings. So you might be running a pod privileged with option A turn on and another one with option A turn off. And we want this option, these choices to be reflected at evaluation time. This becomes even more sensible when we take into account policies that are context aware. Maybe you have the same policy that is context aware deployed multiple times, but with different access levels to the Kubernetes resources. And so we want these access levels to be consistent at evaluation time. We don't want to have them mixed up. And this change was not so easy to be implemented. But as you can see, it was quite an improvement. But once we went down that way, we also started to think about other approaches to this problem, because with this first iteration, we still have duplicated sandboxes of the same policies across the different workers. So if you have 8 workers, like in this case, you're going to have 8 sandboxes, 1 per worker, of the same policy. And this is, of course, a waste of memory, of resources. So how can we avoid this waste of memory? And so we have done more work on this topic, and we ended up with some really good numbers that I haven't yet shared on this pull request. I mean, the changes are all there, and they're ready to be merged. but I didn't post an updated document. So I'm going to show you what I'm going to post on the PR right after this meeting. So this is like, the Excel spreadsheet with the data that then I convert into Markdown on GitHub. So this is the number of workers. This is the current implementation. This is the first optimization that we did. And this is the second optimization that we did. In the second optimization, we are really reusing the sandboxes across all the different workers, and I will share more details about that afterwards. As you can see here, the improvements. This is the improvement of the first optimization. So the improvement of this one over this one. And this is instead the optimization of the improvement of the second optimization over the current one. As you can see, when you have just one worker, the kind of improvement is the same, of course. But the more workers you have, the more optimized we become. So with 8 workers, we end up saving like 70% of resources. And if we plot it, the chart is pretty nice. And as you can see here, this line is basically flat. And the reason why this is flat is because we successfully achieved our goal of having just one sandbox of a policy shared across the different workers. Now, we are not actually sharing the same sandbox across all the workers. I was just simplifying things. So what we are actually doing is we also changed the way that we perform evaluation. So in the beginning, what we did with current implementation and with optimization 1, we actually created a WebAssembly sandbox that then received a request, processed that, and then stayed there in the system, waiting for being used another time by another incoming request. What we are doing right now with optimization number 2 is we are leveraging some low-level facilities provided by the WebAssembly runtime that we are using, which is Wasmtime. We are using what Wasmtime calls instances pre. So instances pre are basically the last step before actually creating a WebAssembly sandbox, because the process of taking a WebAssembly module, a policy, and creating a sandbox out of it requires several optimization phases that take time, and doing that on each incoming request takes a performance toll in terms of a number of requests that you can process and the elaboration time of the requests. And this is why in the beginning with current implementation and optimization number 1, we try to avoid at all costs this initialization time. And we did that by initializing the sandboxes once when policy server starts and reusing them across the life cycle of a policy server. But this approach opens up to memory leaks, because if you have a policy that is leaking, you have this sandbox that starts to grow its memory usage and starts to become bigger and bigger and bigger, and this keeps going until you restart the policy server or until policy server is killed by the out-of-memory killer of the kernel because it was taking too much memory. With this new implementation, instead, what we do is, as I said, we do all the possible optimization, but we do not create the sandbox. What we do is when a request comes in, then we take this pre-initialized state, and from this pre-initialized state, we create the sandbox. This last mile step is not so intense in terms of computation resources, and so it doesn't introduce a significant overhead, and so it doesn't slow down as significantly, but it has several added values. So first of all, we always keep the memory consumption almost stable. If you are, when doing benchmark testing, performance testing against the optimized optimized 2 instance, we see that the memory usage goes up, but then goes down based on how many requests are incoming. Because when no requests are incoming, then the memory goes back to the initial value, all right? And that's because we create the sandbox, we do our own evaluation, and when the evaluation is done, we throw the sandbox away, releasing all the memory that it was taking. So this is also keeping us secure from memory leaks. I mean, a policy could still perform memory leaks, but as soon as the evaluation of a request is done, the leaked memory is released and is collected, and so we do not end up having this situation described by the user with 50 gigabytes of memory used. So we're pretty happy about this change. And what is even more interesting is that by completely changing the architecture that we have, we are also confident that we can remove this worker pool pattern and hugely simplify our code base. So the current plan that we have is to merge the pull request that you have seen above, merge it inside of the main branch, but wait a little before tagging a new release of policy server. Everything seems to be working fine with our automated tests, but of course we want to do some more sanity checks. But on top of that, before doing an actual release, we would like to implement this last optimization I was mentioning, the removal of a worker pool. And here we have already a small proof of concept that works in this way without the memory, without the worker pool. But we want to do for more tests, and of course, actually implement that, because the POC is on a really smaller code base, but we can definitely reproduce what we have done in the POC inside of our actual code base. And so this is what is coming up. I guess this is going to be available to everybody in January, and we will definitely make some big announcement about that because the numbers are pretty good.
It's super great, Flavio. Yeah, sorry. I wanted to ask more about the logs and the threads and so on that we use, no, for the workers. And I see Fabrizio wanted to also say something, so maybe it's related.
Yeah, well, we also removed some locking that we had there because the previous model, let's say between optimization 1 and optimization 2, we were using a model that was using like a global state, let's say, and this global state for some reason needed to be mutable, and then we actually realized that we didn't need that with the instance spray optimization, and so we wrapped up a structure that was encapsulating the logic of retrieving a given policy ID, going back to the policy instance, to the evaluator instance spray, and then we could share this between threads by using just an ARC, an atomic reference counter, and removing the lock at all. And this also increases performances, not on memory usage, but on CPU most probably, and removes a lot of complexity because we don't have to deal with locks and mutexes and a lot of global state which is shared between the workers. We just have this a service that does the evaluation, and we actually instantiate that and just once, and this actually simplifies a lot. And then going in the future, removing the worker pool, we realized that the worker is actually very thin It doesn't do much job except calling the evaluation environment and trying to validate given a policy and retrieving, the evaluation context and the pre-instance of the policy. So we realized that we could maybe remove the worker pool at all, because the only thing that the worker pool was doing is some sort of like rate limiting, so not bloat the CPU with like a lot of requests that would go calling our WebAssembly runtime. So yeah, we baked a little POC by using just a semaphore and relying on probably another framework from the Tokyo guys, which is called Axum, and sharing this evaluation environment between all the requests, and then blocking the capacity of the the evaluation by using a semaphore, and really simplifies a lot, because we don't have like channel passing and worker pool and workers that are always running. We just have a semaphore, and when we receive a request, we ask the semaphore if we can do the evaluation. Otherwise, we wait for the green light, and then when we get the green light, we do the evaluation, and we respond to the HTTP stack. So that could be something that we want to implement in the future.
Yeah. Another thing I forgot to mention. Did we answer all your questions, Victor? Sorry.
Yeah, I think it was perfect. Yep.
Okay. Another thing I forgot to mention is, as a side effect of these changes, especially the last one, we also reduced the bootstrap time of a policy server, because now we are doing this initialization of the policies just once, while before we had each worker doing its own initialization of the policies, the creation of all the sandboxes. So now this is no longer done. There are also other things that we might want to explore in the future, and this is all depending on your feedback. So as you can see here, the baseline is constant, but for some people might still be considered too high, and this is just because, this is the amount of memory that a WebAssembly sandbox takes. It all depends on the size of the policy, or the symbols inside of it. But we can't go below this value unless we start to offload these pre-initialized instances. Like, we could keep them in memory for some amount of time, and then after some inactivity, if a policy is not used for, I don't know, 2 minutes, 3 minutes, we just throw away the pre-initialized object, and by doing that, we just reduce the memory usage. And then when a request comes in for this policy that has been let's say tossed away from the cache, we just read it again from the file system, because it's still there. We downloaded it, and we just go through the initialization. And there is some caching mechanism built into wasmtime that speeds up some portion of this project, so of this process, and so we can take advantage of that. However, we don't want to reach the perfect solution and just postpone the release of this improvement forever. So we are big fans of agile and iterating over features and improvements. And so we really want to push out optimized version number 2 during the month of January. The worker pool removal that Fabrizio was mentioning, we wanted to be there, to be part of it. But I do not expect this refactory to lead to better numbers, because it's just an internal code reshuffling, which is awesome because, as we said already many times, it simplifies our code base, but is not going to give us more better memory usage or better performances. So yeah.
Can I have a question?
Yeah.
You at the beginning, when you mentioned workers, I was not sure what workers you mean. So at first I thought, yeah, it's a Kubernetes node as a worker.
Mm.
So then I realized it's another thing. But could you explain a bit more, like what worker is? You said it's some in a number of CPUs maybe.
Mhm.
But can I change the number of workers that
Yeah,
I
sure.
use, or what is that?
Yeah, that's a good question. Thanks for pointing it out. So we are not talking about Kubernetes concepts right now. We are just talking about policy server and policy server as an application. And so we can forget about containers, Kubernetes at all right now. So policy server is a webhook server. So it is exposing some HTTP endpoints that are being used by the API server. The API server is making post requests against these HTTP endpoints, and it is sending to policy server the admission reviews. That's the object, admission request review. Yeah, okay. There are so many admission types that I get confused. So it is receiving this object, and then this is a JSON object that we have to validate. So the validation has to be done by a WebAssembly policy. So we have a WebAssembly sandbox, and we give to the sandbox the JSON, and we obtain a response: accept, reject, mutate, and then we give back this response to the API server, who is waiting for this response on the HTTP communication channel. So the thing is, we get many incoming requests, and so we cannot have everything processed just by one, and we can run just one sandbox at a time. So we cannot have the sandbox process to block everything, And so when we talk about workers, I'm talking about a pattern used when you have like a stream of data you have a stream of producers that are creating working items. In this case, requests to be analyzed. You don't want to be blocked by having just one worker that is processing these requests. So you have many workers. So you create a worker pool, which is basically to go straight to your question now. A worker pool is a set of threads that are spawned by the policy server process. So it spawns these threads, and each thread is in charge of doing WebAssembly evaluation. It can do just one evaluation at a time because it is running one sandbox at a time, because when you're running the WebAssembly sandbox, everything is blocked, waiting for this sandbox evaluation to be complete. And so the more workers you have, the more processes you can handle in parallel. And this is why we allow the user to set the number of workers, but if the user doesn't give us a value, we determine the right number by just looking at how many cores your machine has, because there is, this is a common problem. If you exceed a certain, you cannot just start infinite threads on your machine. At a certain point, the more threads you have, the worse actually the performance of your application will become. And so what we do is we just you have one core. You have 8 cores on your machine. So we will start one thread per core. And it's up to the kernel then to do the scheduling and all this stuff. But usually this is a good enough solution to determine how many threads you should be starting. So this is what I was referring to.
Yeah, great. Thank you.
Yeah, you're welcome. This is it for this topic, I guess. And this was also the last topic we had on our agenda, or
Yes, I remember one actually, which is the survey. So maybe a quick shout out to the 2023 user survey, which
Yeah. So we would like to. We have seen people coming on the Slack channel, or filing issues, feature requests on GitHub and such. We would like to know more about the usage you're doing of Kubewarden, so that we can better prioritize our agenda, the features that we want to deliver, or the areas that we want to invest on. And last but not least, this is also a call for help, because Kubewarden is a CNCF project. Currently, it is a sandbox project, and we would like to apply for the incubation level, which is the next level inside of CNCF. We would like to do that during next year. But in order to do that, one of the requirements that CNCF has is to come up with a list of people or companies that are using Kubewarden in production. So we have this adopters file that is inside of our GitHub repo of the Kubewarden controller that already has some names on it, but we need more names, and we know that there are people using Kubewarden in production. So if you want to help us, if you want to help Kubewarden, please don't be shy and add your name over there. And this is one of the things that is pointed out inside of the survey. So I don't remember exactly when do we want to share the survey. We want to do that next week, if I'm not mistaken.
sounds good. Yeah.
Yeah.
We can do
So
it on a blog post or share it.
Yeah, we plan to do a blog post during the next week before going on vacation for Christmas time. We want to send up the usual blog post that we do every year with a recap of what happened during the year inside of the Kubewarden project, and we will also put a link to the survey. We will also spam you on the Slack channels, with a link to the survey. It's completely anonymous. We do not collect any data about you. We just ask some generic questions about your usage patterns of Kubewarden, and what you would like us to work more the areas that are relevant to you. And of course, we will share the results of the survey once this is over. I don't know how long we will keep it running. Hopefully, as long as we have, we need to gather some data. Please send some data to us. This is going to help the project to improve. That's it, I guess. So this was the last community meeting of 2023. On behalf of the Kubewarden developers, I wish you Merry Holidays, and we'll see you in 2024. Have a great time. Bye-bye.
See ya.
See you.
See you. Many thanks.
Bye-bye.